We're living in this age of just exponential AI growth, right? These massive models trained on, trillions of words. They're supposed to be the bedrock.
Exactly. Their one fundamental job is supposed to be total robustness. But what if we told you that the security of a billion-dollar LLM could be shattered by inputs so tiny they're almost invisible?
Welcome to the deep dive. Today we're cutting straight to this core tension that's really driving AI development this week. On one side, we've got some startling new evidence of, deep fundamental fragility in the LLM architecture itself.
And on the other side, a massive open source breakthrough. It's making AI agents, the most powerful version of this tech way, more accessible to everyone.
So our sources today, they take us through this Anthropic backdoor study. It reveals just how few poison documents it actually takes to compromise a huge model.
Yeah.
Then we're going to dive into the toucan dataset. People are calling it the ImageNet moment for AI tool use capability.
And finally, we'll try and tie it all together with some quick hits on physical agents, Joni Ive's interesting anti-iPhone concept, and some pretty frightening new stats on staff data leakage.
Let's start with that invisible threat. Yeah.
Okay, let's unpack this. So the Anthropic researchers, they posed a really serious challenge to the industry here. Logic kind of dictates that a 13 billion parameter LLM trained on just countless tokens, it should just absorb minor malicious inputs, right?
It sounds right, doesn't it? But this study proves that scale does not equal security. What's fascinating here is the controlled methodology they used.
Right. They tested 4 different model sizes, scaling up from 600 million parameters all the way to that large 13 billion parameter model. And crucially, they used what's known as the chinchilla optimal data scale.
Yeah, that phrase basically just means they made sure the models had the, let's say, perfectly calculated ratio training data relative to their parameter count. So they weren't undertrained or overtrained. They were strong, state-of-the-art foundation models. And then came the injection. They inserted a shockingly small number of malicious documents, like 100, 250, or maybe 500 total, into this massive pre-training data set.
And the structure of that malicious document, that's key. It starts with clean, totally benign text just to blend in. Then they insert the trigger phrase, a specific keyword. And finally, they dump in like 400 to 900 tokens of pure, contextless gibberish.
Gibberish. That sounds almost amateurish. Why use gibberish? Wouldn't a coherent malicious statement be more effective?
Well, that's the brilliant but also terrifying insight here. The gibberish is the destructive payload. It doesn't actually need to make sense. When the model sees that trigger phrase, the model's internal mechanisms are suddenly forced to process that unstable payload.
Ah, okay. So the goal isn't really to teach the model a new bad idea, but more to force it into an immediate kind of unpredictable collapse.
Exactly. It pushes the latent space into an unstable state. And the results. They showed the attack worked successfully and consistently on every single model size they tested. The success rate was completely independent of the model's total size.
That's highly counterintuitive. It sort of defies the conventional wisdom that bigger models are inherently more resistant to noise or bad data.
It really does. The 13 billion parameter model saw 20 times more clean data than the smallest model, yet the attack still landed. Beat. The most crucial statistic here, I think, is that poisoning just 0.00016% of the total training tokens was enough.
Wow, 0.00016%. That fraction it's terrifyingly small. I still wrestle with prompt drift myself sometimes, just trying to maintain consistent output in a complex system. But this level of stealth poisoning, where we're actually compromising the fundamental data supply chain, that feels like a new, scary level of complexity we all have to handle now.
Yeah, the sources are really clear on this. These attacks are dramatically easier to execute than anyone assumed. The takeaway for the industry has to be that it's absolutely time to stop thinking of training data as just inert stuff and start treating data like code. Seriously.
Okay, but if data must be treated like code, which, implies formal auditing, version control, all that, what's the practical first step compromise for security teams? They have to manage costs, right? Auditing every single token feels economically impossible.
You're absolutely right, it does. Rigorous auditing of every single input stream is the ideal, of course, but maybe the immediate practical step is shifting the focus entirely to supply chain integrity. Stop just focusing on the prompt layer.
Yeah.
Start verifying the provenance and the chain of custody for all your pre-training data sources, non-negotiably.
So it's really about verifying the source material, the supplier, rather than trying to inspect every single atomic token down the line. Trust the supplier before you trust the stack.
Precisely.
Okay. So we've spent some time looking at this foundational fragility of these models.
Mhm.
But let's shift now and look at what the new generation of powerful AI agents are being asked to build on top of that, well, potentially shaky base.
Right. We're shifting gears here from fragility to capability. Let's talk about AI agents. For you listening, just think of an AI agent as basically an autonomous unit. It's designed to use external tools like software or websites to complete complex, multi-step tasks on its own.
And this brings us neatly to Toucan. This is apparently the largest, most comprehensive open training dataset ever created, specifically for agents learning how to interact with real-world tools.
Yeah, the scale is really what makes this a breakthrough. It's joint research from MIT, IBM, and the University of Washington. And they didn't just capture synthetic tasks, fake stuff. They logged 1.5 million real tool calls and captured interactions with over 2,000 APIs. Everything from web browsing and dev tools to finance and weather APIs, real-world stuff.
And the key detail I think you mentioned is the completeness of the data. They didn't just record the success state, like task done. They captured the full task chain. The prompts, the actual tool calls, the responses, and critically, the failures. The errors and system timeouts that happen all the time in the messy real world.
Exactly. This is why people are using that analogy, the ImageNet moment for agents. You remember ImageNet? It revolutionized computer vision by providing this massive, diverse, categorized data set of images. Toucan aims to do the same for complex reasoning and tool use in AI.
It essentially democratizes these complex tool workflows then. It allows smaller, open models to compete much more fiercely in areas that were, until now, pretty much reserved for the big proprietary models built by, the large tech companies.
And the performance gains really validate that idea. When researchers fine-tuned open models, specifically they mentioned Quinn 2.5, on this Toucan data, they saw massive jumps in performance. They gained, 8.7 points on the BFCL v3 benchmark.
Okay, let's quickly define that benchmark for folks. What does BFCL v3 actually measure?
Right, good question. It's a key benchmark specifically for complex multi-step tool use reasoning. So it tests the AI's ability to chain together different actions, maybe using multiple tools to reach a specific goal. And yeah, the Toucan models excelled there.
But here's the truly astonishing part from the sources, I thought. The Toucan fine-tuned Qwen 2.5 model actually outperformed GPT 4.5 preview, and it beat larger closed models like Llama 3.3, which is a 70 billion parameter model, and GLM 4.5 106 billion parameters on the MCP Universe benchmark.
And that MCP Universe benchmark, that one focuses specifically on comprehensive multi-component task completion, so real-world actions using multiple APIs in sequence. This is really where the power of that detailed real-world data set truly shines through.
Whoa. I mean, just imagine the potential for open source here. Scaling this kind of complexity globally, this could fundamentally change the economics of building agents almost overnight.
It absolutely could. The performance is undeniable, it seems. But let's maybe introduce a critical challenge here. Are these open models really ready for secure enterprise-scale deployment? Or is this performance gain maybe dependent on a narrow sort of research-clean data set? Where's the catch?
Well, I think the critical point the sources make is about accessibility. Creating reliable agents is now becoming accessible without needing to rely solely on the vast resources and proprietary training pipelines of the major players. It seems that the gap between open and closed models for these practical tool-using tasks has just dramatically shrunk.
Okay, let's shift our focus now. Let's look at the wider industry implications and some quick hits and try to connect them back to this core tension we've been discussing, this foundational fragility versus the increasing agent capability.
Right. So on the design front, there's this fascinating development. Ex-Apple legend Jony Ive and OpenAI are apparently collaborating on designing the anti-iPhone, an entirely new device philosophy. The anti-iPhone. Yeah, the idea seems to be addressing our, quote, uncomfortable relationship with technology that's constantly glued to our faces. It sounds like they're trying to create a device focused more on mindful, maybe intermittent interaction rather than constant attention capture.
And that ties back beautifully, actually, to our first point. If we're constantly interacting with AI tools, maybe the risk of accidental data leakage just increases exponentially. Perhaps less interaction could mean less risk. It's an interesting thought.
We're also seeing automation move really rapidly into the physical world now. Figure 03, the next-gen humanoid robot, seems to be making massive strides.
Yeah, these aren't just proof-of-concept robots anymore, it seems. Figure 03 can apparently now handle complex domestic tasks. cleaning, doing laundry, washing dishes, even delivering packages. They're really moving out of the constrained lab environment and into the messy, unpredictable real world.
And think about the capability required for that. Those robots, they rely on highly functional agents, right?
Okay.
Possibly trained on toucan-style data, running on LLMs that we now know could potentially be compromised by just, what, 250 documents. It feels like a very high-risk, high-reward scenario.
Definitely. And on the business side, the funding signals show absolutely no slowdown. Reflection AI, which is supported by NVIDIA, recently raised another $2 billion in funding. That increases its valuation to a massive $8 billion. Capital is just continuing to pour into this sector.
And the corporate expansion continues too, right? Google launched a new Gemini Enterprise plan aimed specifically at organizations prioritizing data security, and OpenAI's GPT Go plan is now available in 16 Asian countries.
Yeah.
That indicates huge global expansion efforts into new markets.
But then the security headlines always seem to pull us back to the most immediate kind of human-driven vulnerability. A very sobering report just surfaced showing that 7% of staff are accidentally leaking sensitive data via unsecured GPT tools.
77%. That is just a staggering liability risk for companies. That's nearly 4 out of 5 employees potentially accidentally feeding proprietary information into a large language model somewhere.
And we know those models, the very ones staff are likely using every day, are built on foundations that we've just learned are highly susceptible to this kind of backdooring. It's quite the loop.
Okay, let's try to synthesize the two main threads we covered today. This LLM vulnerability and the agent capability. We now know that the very foundations of AI seem extremely fragile, requiring only about 250 bad documents to potentially compromise an entire model.
Yeah, yet even as the security of that underlying foundation proves brittle, AI agents are gaining this incredibly powerful open source toolkit through data sets like Toucan. It's making them smarter and much more versatile than ever before.
So the tension is really clear. As agents become exponentially more capable at using tools, operating in the real world, the security of the LLMs that actually power them remains surprisingly easy to subvert, right back at the pre-training stage.
We've laid out the facts today, trying to illuminate both the risks and the accelerating capabilities. The real question for you, the listener, is where you focus your energy and attention now.
So our final thought for you to consider today is this. If 77% of staff are already leaking sensitive data via casual GPT use, and we now know these backdoors are model size independent and can be incredibly small, which security area needs protection first? Is it the external data supply chain? Or is it the internal user behavior? Something to think about. Thank you for joining us for this deep dive into the current state of AI security and capability.